next topic is the three states of matter. We have seen matter in the previous class. The three physical states of matter, physical states in the sense the matter is classified on the basis of physical properties, their shape, volume, compressibility, particle forces, etc. Among the three states of matter, we have solids, liquids and gases. Coming to the first physical state, solid. Solid is that form of matter which possesses rigidity, incompressibility and hence has a definite shape and a definite volume. You can see lot many examples given in this slide. The brick, the stone, glass, chair, mountain, tire, etc. All these are characterized by their rigid shape, they have a definite volume, they are almost incompressible. As you apply a force, they cannot change their shape. Coming to liquids, liquid is that form of matter which possesses fluidity but they are almost incompressible. They have a definite volume but there is no definite shape for liquid substances. You can see water is the best example, oil, soft drinks, etc. They all are characteristics. They all show characteristic properties of liquids. Coming to the third physical state, that is gas. Gas is defined as that form of matter which possesses fluidity but highly compressible. They have neither a definite shape nor a definite volume. Air, oxygen, hydrogen, nitrogen, all these are gases. They do not have definite shape, also they do not have a definite volume. Coming to the properties of solids in detail, we have the first property, that is solids have a definite shape. The explanation, they have very small interparticle distances. You can see the particles are very closely packed and there are strong interparticle forces of attraction. Interparticle means between the solid particles. They have distinct boundaries. They do not change their shape when they are put in different containers. Hence, these are characteristic of solid substances. They have a definite shape because they do not change their shape often. Hence, we consider them as solids. The second property, solids possess a definite volume. Due to the small interparticle distances, they cannot be compressed because particles cannot come closer to each other because they are very tightly or very closely packed. Hence, the particles cannot be brought closer to each other. There are a few exceptions. One such exception is sponge. You can see that as we squeeze a sponge, you can see that its shape changes. It is because it has minute holes in which air is trapped. As you press it or squeeze it, the air molecules get expelled. Another case is rubber, that also holds as an exception for solids which possess indefinite volume. Solids possess the property of rigidity. The rigidity means solids have the tendency to maintain the shape even when some outside force is applied. Say for example, we consider pipe or say a brick or a stone. When even as we immensely apply a force onto such solid substances, they may never change their shape. Hence we call solids as rigid. When they are dropped, put down, or when they are hammered, they will easily break also. Solids have high interparticle forces of attraction because the particles are very closely packed. You can see the crystal structure of a solid with violet and green balls present over here. The particles are very tightly packed. You cannot see even a small amount of empty space. The particles are so tightly packed that the forces of attraction between them are very high. That is why particles are not separated easily. Solids have the least interparticle distances. Since particles are very tightly packed, like say table salt or ice, etc., the forces of attraction between them are maximum. Hence, the distance between them is least. Next property is that the solids are completely incompressible. We know a brick, unlike sponge, you cannot squeeze or press it. They are almost incompressible. They are completely incompressible. Next one, solids have a very high density. You may be familiar with the term density. Density is equal to mass upon volume. The high density is because many number of particles occupy a given volume in a solid. Next, particle motion. Due to small interparticle distances and strong forces of attraction, the particles of a solid do not move much from one place to another, but they can only vibrate about their mean position. Mean position means fixed position. Thus, they have only vibratory motion like the strings of a veena or say tamburu, etc. Particles of solid have minimum energy. As they are unable to move, the energy associated with them due to their motion, that means we normally consider the kinetic energy, is the least for solid substances. Next one, solids do not show the property of diffusion. The intermixing of particles of different types of matter is called diffusion. Solids do not show this property because the particles are held by very strong forces of attraction. You can see the incense stick, which when burned, the fumes or the fragrance move from the one place to the other through air as the medium. In such cases, diffusion is more, but in solid substances, the diffusion is least. Properties of liquids. Liquids have constituent particles which are less closely packed. That is why we can see that liquid particles can move from one place to another. See the number of liquid particles present in the container. They are very small as compared to the number of particles present in a solid substance. Number 2, the interparticle distances are larger than solids but smaller than those of gases. See, for the comparison, solid and liquid substances are given together. Solid particles have very small space between them. Liquid particles have comparatively larger space as compared to solids. Next one, liquids do not have a definite shape, but they have a definite volume. A liquid usually takes the shape of the container in which it is being filled. Like we can pour liquid in different containers. We cannot define a shape for any particular liquid. In turn, we can measure the volume of liquid being taken in a particular container. Say we take 100 ml of a particular liquid or say 25 ml of a particular liquid. You can measure its volume, but there are no means to measure its shape. We say liquid substances do not have a definite shape, but they do have a definite volume. Liquids do not possess rigidity, but the property similar to those for solids, they are defined as fluidity. Or we say liquids are fluids, that means they can flow from one place to another. There are larger particle distances, interparticle distances. They are held only by weak force of attraction as compared to solids, hence they can flow from one place to another. They change from, the fluidity can also differ from one place to one liquid to other, like water can easily flow, honey cannot flow easily. Next property of liquids. Particles of liquids have greater freedom of movement than that of solids. Here also we can see the solid particles, that means the first diagram shows particles which are very thickly packed, but liquid molecules have some space between them so that they can move from one place to another. That is why we see water is flowing, oil can move, honey also can move, like that. Next one, they have higher energy as compared to that of solids. In solids we have seen the energy which is mentioned here is the kinetic energy, that is energy as a result of motion. This is more as compared to that of the solid particles because there is space and they are also held by weak force of attraction. Seventh one, the density of liquids is lower than those of solids. You can see in case of a solid substance like say ice, the density is more, but liquid water has comparatively a lesser density. Some substances, there are certain solid substances, because of their density they go down, whereas in some other cases you can see like plastic cork, the plastic block, etc. mentioned in the diagram, they have comparatively lower density, hence they almost float. Oil has a lesser density, hence it flows above water. They show the property of diffusion, as we have seen in the solid case. The movement of particles or intermixing of particles is referred to as diffusion. When you drop a small piece of potassium permanganate, say in the second figure, the color of this particular solution, that means in water, the color progressively increases. You can see in the first case, the colored matter slowly progresses into the solution itself. Therefore, the property of diffusion is seen with respect to liquid molecules, because the particles which are added can easily go into the interparticle spaces between the liquid molecules. Coming to the third physical state of matter, that is gases, the properties associated with them, the constituent particles have very high freedom of movement. We say always gas spreads throughout the container, gas molecules are always in motion. The gas molecules can very easily move from one place to another, because they have the second one, the interparticle distances are very large and the forces of attraction between them are very weak. The next important property is gases do not have a definite shape, they do not have a definite volume also. They have neither definite shape nor a definite volume. They are highly compressible. This is a very important property, because as we apply force or say pressure to a gaseous substance, you can see that the particles were initially, they are quite at a longer distance from each other, but as we apply a pressure, these particles can very well come closer to each other. The compressible nature of gas holds very good, because any gas can be compressed to get a liquid substance, like carbon dioxide can be liquefied, nitrogen, there are other gases like ammonia, etc. those can be liquefied. That is because they are compressible. As we apply a force or a pressure, the particles can come closer to each other and they start attracting each other. We say they are compressible. The syringe with the piston, as we move the piston inwards, you can see there is a slight difficulty in moving it into the syringe, because the air molecules are present there, which usually possess a force or a pressure, but you can still move them closer to each other because there is inner space between the gas molecules, they can be compressed. Gases flow more easily than liquids and have the highest fluidity. Their movement is very high because of two specific reasons. One is that they have high force, they have very low forces of attraction among themselves, and the distance between the particles is very, very large. The other properties are, they have the highest freedom of motion because they are held by weak forces of attraction. They have the highest kinetic energy because they are always in random motion. They have the least density among the three states of matter. They weigh the least and they diffuse very rapidly. In the figure you can see there are lot many molecules. Before diffusion the molecules are present, and once they diffuse the particles are intermixed homogeneously. That means they are intermixed uniformly. Now in the second figure you can see bromine, which is a brown colored gas. One half of the container was transparent or colorless, but after diffusion the entire apparatus or the container turned brown in color.